Hello, this is Nostradamus. Today, I'd like to discuss the role of negative feedbacks in our warming world. Most people are familiar with positive feedback loops, where we run the risk of a runaway greenhouse effect as temperatures rise. The most well-known one probably being the reduction of the albedo in the Arctic as the polar ice cap shrinks in size. More heat gives rise to greater melt, which opens up more ice-free ocean, which can then absorb more sunlight in a vicious cycle where less and less of the sun's radiation gets reflected back into space. The Earth's climate has remained fairly stable since the last ice age, allowing mankind to build our civilization with global average temperatures confined to a narrow variation of less than 1 degree C. I believe that there are natural processes which take place that regulate the planet, that keeps the climate in balance. But now we have interfered with the equilibrium, and the Earth's defence mechanisms are being activated in an attempt of restoration. It is these negative feedbacks I would like to talk about today, and just how much potential they have to affect our climate. I would like to begin by examining the jet stream, which marks the atmospheric boundary between the cold, dry polar air mass and the warm, moist air around the planet. The rise in global temperature has not been uniform, with the polar regions warming faster than the lower latitudes. This has reduced the temperature gradients between the poles and the rest of the Earth, resulting in a much weaker jet stream, which now has more of a tendency to become wavier and stuck in place. This is having a profound effect on our weather, where many areas are being subjected to prolonged periods of drought, or alternatively long spells of excessive rainfall. So what effects could these droughts result in? As vegetation dries out, it becomes more and more prone to the risk of a wildfire breaking out. Particularly large fires can inject soot particles high into the atmosphere that can reduce the amount of solar radiation reaching the surface. Before I move on to flooding, I would like to touch on the solar minimum we are now experiencing. It has been calculated that even a major solar minimum by itself results only in a fraction of a degree of cooling of the planet. The main consequence of a solar minimum is the reduction of the solar wind, allowing more cosmic rays to bombard us from outer space. I believe an increase in cosmic ray exposure leads to increased volcanism, which we may be witnessing right now. Another factor that may lead to increased volcanism can be traced to global warming. As large land-based ice masses start to melt, the ground beneath can start to rebound as the sheer weight of the ice above starts to diminish. This could have huge implications regarding worldwide tectonic activity, awakening long-dormant volcanoes. All the extra ash and gaseous emissions would have immediate effects on the Earth's climate. The picture on screen is Mount Sinabung in Indonesia from last week, erupting to an estimated 58,000 feet. Now on to rainfall. As the atmosphere heats up, its ability to hold more water vapour also increases. A raindrop needs a particle in the air to condense upon before it can be born. So we now have more smoke, more volcanic ash, and even some nanoplastics around to help the increased amount of water vapour form into precipitation. More rainfall, more evaporation at the surface, more reflective clouds, and more powerful storms that can even eject energy into space can all combine to give an overall cooling of the Earth. Also, increased frozen precipitation at high latitudes will add to the albedo effect. The final negative feedback to produce cooling as a result of a warming world is the slowdown of the thermohaline circulation. Recent measurements suggest it has already reduced by as much as 20%. We are in uncharted territory. There are large amounts of warm Atlantic salty water entering the Arctic Ocean, mixing with the cold freshwater runoff from Greenland. This is affecting the natural sinks of the ocean and may severely impact on the future strength of the global ocean currents. This is a comparison of Greenland today and 12 months previous. Why does this matter, and how could it cool the planet? As the circulation slows, less and less warm tropical water will reach the Arctic, giving it a chance to refreeze in winter. This could, theoretically, take us into a new ice age. Looking back at the geological record, the amount of CO2 in the atmosphere does not always correlate with the global temperatures. Around 150 million years ago, a rise in carbon dioxide coincided with a reduction in temperature. It is my hypothesis that negative feedbacks were involved and that the cooling was in response to increased greenhouse gas concentrations. The reason I am presenting this video now is that I made some unusual observations yesterday. I regularly use the NOAA Climate Reanalyzer product to keep up to date with what's going on with the climate. Ever since I first discovered the site about 2 years ago, the 2-metre atmospheric temperature anomaly has hovered around plus 0.6 degrees C, give or take 0.2. However, the latest measurements for the anomaly, which shows global change since the 1979 to 2000 average, is showing a drop of 0.1 degrees C. There are already signs that this is affecting the rate of Arctic melt. As if that wasn't enough, the drop is predicted to reach minus 0.5 degrees Celsius by the 23rd of June. This would represent a global reduction of average temperature of more than 1 full degree Celsius within the space of a fortnight. In conclusion, either the natural negative feedbacks I have identified are kicking into effect with no knowing how far the temperature will drop, or someone out there is doing some serious geoengineering. Personally, I think the climate will flip-flop for a time before we end up with either hothouse Earth or an ice age. A battle of nature is underway. It's 50-50 in my book.